Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Montakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to Scott Heide, founder and CEO of Engineering Intent, which provides a powerful cloud-based software application for designing anything from machine parts to full houses and buildings. One of the things I found interesting about the software is that it automates much of the design process using what's called rules-based generative design, as Scott explains in the Q&A after his presentation.
Yeah, I am Scott Heide. I'm the CEO of Engineering Intent and also the founder. Um, I've been doing this kind of design automation and engineering automation for about 30 years. And my background is a combination of engineering and computer science. I have an undergraduate degree in mechanical engineering and a graduate degree in computer science. And throughout my career, I've been working in this combination of engineering and computer science and how those things come together to make the process of engineering more efficient.
Okay, Scott, if you don't mind going ahead and making your presentation.
Yeah, so we are engineering, the company is Engineering Intent. As I mentioned, it was founded about 10 years ago. We focus entirely on doing design automation, engineering configuration, sales automation, and sales engineering configuration types of applications. That's all we do. And it's our expertise, and we kind of consider ourselves a leader in that industry worldwide. We have offices here in the, or employees here in the United States. And then we also have a small office in Germany and Japan, and then an offshoring team in Minsk, Belarus. We focus on helping companies that make customized products that are customized to the specifications of each customer as they place an order. For many companies, the ability to do this kind of customization is a key differentiator in their business. They can make a product that's specific to their customers' requirements where a mass-produced product may not fit that bill. The problem is that customization introduces longer sales cycles, makes it difficult to scale, introduces operational inefficiencies, and so on. And so the challenge is to be able to do this kind of customization while addressing those challenges. The goal is that a customer comes and they make a request, and what we want to be able to do is enable our customers to be able to respond to those requests quickly and efficiently to reduce the friction and the roadblocks in whether it's the pre-sales process of getting a quote or a proposal back to the customer, or it's the post-sales process of delivering the product to their customer. Both of those operations tend to take a lot of time and have a lot of challenges. So for companies that make customized products or engineered to order products, the business process is pretty complex. They have to get information from their customers. They have to do some preliminary design. They have to bring engineers and get them involved. They have to go through a lot of steps to put together a quote and estimate their margins and so on. It's a time-consuming process. They're not getting paid at this time, and they're utilizing valuable time of engineers um, in a way that's not being directly paid. It's also prone to mistakes, and it's also difficult often to create a compelling proposal for a customer, a 3D model, a drawing that if you had time, of course, you would do it, and it would increase your chance of making the sale, but it's so time consuming and difficult that often it doesn't get done. After the company gets the order, similarly, there are a lot of steps and handoffs for preparing a product for manufacturing and ultimately getting it to the customer. It involves a lot of engineering time. It involves typically a lot of calendar time. There's a lot of expense. The manual operations are prone to quality issues and errors, and it's just not a very efficient process. So the goal is to capture the design and configuration rules into a single source of truth, if you will. And to the degree that we can capture that, those rules about how that product is designed, how it needs to be built to match the customer's requirements, how it needs to be designed to be manufacturable. If we can capture those rules, then we can automate many of these steps. And when you automate the steps, you reduce the costs, you increase win rates because we can now do a much better, quicker, easier proposal document, for example, and you can scale. A lot of the companies we talk to, they may be smaller companies in the Midwest or in places where it's difficult to just go out and hire a lot of new designers, draftsmen, and engineers and train them and have them understand. But if they can automate the process, they can scale their business without having to scale their manpower so much. So when we built the product, Knowledge Bridge, there were three things we wanted to take into account. One of them is what we call capture requirements directly in the software. And what that means is this type of configuration, traditionally, if it's done at all, is done with computer programs, just sending the programmers into the corner, letting them write complex, big programs. The programmers often don't understand the product design and the rules. There's often miscommunications. They end up with a big program that, if it succeeds at all, is very difficult to maintain over a period of time because of these communications and disconnects between the people who are creating the rules and the people who are maintaining them. However, if we can make it easy for the engineers themselves to capture those rules, then that problem goes away to a very large degree. Configure the product model visually. So for a lot of these engineered to order products, in order to understand them, what you're getting, what you've configured, you need to see a live configured model of it. And just as importantly, often you need to interact with it. You want to point and click and grab and drop and, do those things that, you like to do with your Apple computer there, to interact with it visually. And that's an important aspect. And then finally, we emphasize the ability to generate the documents that are needed, whether it be a proposal document up front, a sales drawing, a submittal drawing, a CAD model, a drawing, CNC, bill of materials, things like that. And to do this, we developed this product we call Knowledge Bridge, or K-Bridge for short. A key element of Knowledge Bridge that differentiates it from virtually everything in the market is that it unifies configuration rules, engineering rules, user interface rules, geometry rules, and business rules. There's a lot of configurators out on the market, but those configurators don't do engineering rules, they don't do geometry directly, and they certainly don't customize their user interface driven by the rules, and don't do it in the context of business rules. So in order to automate these to-order products, these engineered to order, configured to order products, you really need all 5 of these things. And that's kind of the special sauce that our product Knowledge Bridge has. And ultimately, the goal is that our customers write the rules and the software is generating the product model for them. Couple of typical applications. So we have on the left, one of our largest customers is a company called Takanaka. They're a $20 billion construction company out of Osaka, Japan. And we've automated several things in the building design area with them. The one you're looking at is a ceiling plan automation system that lays out the lights, the HVAC, the fire sprinklers, the speakers, and all of that based on rules for spacing and interference and so on. And they are able to now do these kinds of layouts across, for example, a 50-room, 4-story building here in a matter of minutes, what previously would have taken literally dozens, if not hundreds of man-hours of work to do. That company also has a pipe routing automation program from us that they've built with K-Bridge. And so they have several different applications, an equipment layout application as well. Our more traditional market, frankly, is companies that make mechanical equipment. And this company, Monkey Toe, is a company in New Zealand that makes these platforms that hold equipment on top of buildings. And so they use our graphical interface to indicate where the equipment is going to be and what the loads are going to be. And then they have an integration between Knowledge Bridge and a finite element program to size and select the actual individual structural members. And then K-Bridge does the design, does the drawings, creates the proposal document, estimates the cost, and so on. And so it's a pretty comprehensive program. It's enabled their sales guys in the field to be able to quote one of these platforms in a, when previously they would have had to come back in-house, had engineers touch it, go through a whole laborious process, but now they can do it right on the website. The benefits of Knowledge Bridge range across the business process, and up front, it's about being able to create a compelling, fast, accurate quote while understanding your margins, making it possible for more people to do the quote, whether that be your dealers or the people out in the field. Downstream, it's about efficiency. Typically, you want to be able, once you get that order, you want to be able to prepare it for manufacture as fast as possible. And it's about reducing engineering costs, reducing errors in the process, and just overall shortening the time to delivery. And we have a lot of companies that have done this kind of stuff with K-Bridge already. Just as an example, this company, Cleveland Price, does high voltage switching equipment. Monkey Toe, you just saw, that's the platforms. This is an elevator company. This is a company that makes heating systems for buildings. This is a rooftop HVAC application, radiator coils, conveyors. We do a lot of material handling type operations, custom furniture, ducting, and this is configuration of electrical equipment. And so we have a lot of broad range of applications. The common theme is that each product is an engineered to order product, and we're able to automate that design and configuration process. So just double clicking on the three concepts. The rule writing is done in a way that's kind of like doing a spreadsheet. The rule writer makes declarations about the relationship between properties of an engineering object. In a spreadsheet, you make declarations about the relationship between cells. Column C equals the sum of column A and column B. The spreadsheet keeps track of that for you, and that's what makes it possible to create some pretty complex programs with a spreadsheet that, you know, by people who aren't programmers. And similarly, we make, the way rules are written in Cambridge is we make declarations about the relationships between the properties of objects, and those declarations are kept track of by Knowledge Bridge. And so it makes it relatively easy to do. Obviously, it's more complex than a spreadsheet because we have multiple objects and so on, but fundamentally, it's like setting up a spreadsheet. Configure the product model visually. As I said, for a lot of products, you need to be able to see visually what the product looks like, and you need to be able to interact with it to get it configured properly. And we have advanced capability for both, for visualization and for interactivity. And then, you know, the outputs, we'll talk more about this as we go, but, you know, we can output drawings, we can output documents, we can output models, we can output bills of material, and so on. So I skipped over that. Knowledge Bridge is a cloud-based system. If you have an internet and you have a mouse, you know, in a browser, you can run it. You don't have to have any CAD system or anything installed locally. And this makes it really easy for us to manage, for our customers to manage and deploy and update their applications. The IT infrastructure is virtually zero. This graphic sometimes works and sometimes it doesn't. I've got a backup here for when it doesn't work. Let's unhide that there. I got to get rid of this. Sorry for my fumbling around here. There's built-in graphics in Cambridge. It enables us to provide a 2D or a 3D view of the product. It's very lightweight. It's very fast. I'll maybe demo this house to you in a few minutes. It takes a matter of seconds to regenerate it and redesign it, and is very interactive. We can do rendering, lighting, shadows, you know, make things like furniture and other products that need to look good. We have the ability to do that on the fly. It just happens automatically. And as I mentioned, we can generate drawings. So being able to do that drawing right in the field, again, without the CAD system, if needed, is a huge benefit. And this gets used for sales drawings, submittal drawings, things like that. We have this concept called EPQ, which is Engineer Price Quote. You know, you may have heard of CPQ. It's kind of a common term for Configure Price Quote. But as I mentioned, configurators can't do engineering. And what K-Bridge does is a true engineering configuration. And we've put that together, coupled that with an ability to do management of accounts and opportunities and quotes and approval processes. And with this layer on top of it, we call that combination EPQ. I mentioned integrations, so we have out-of-the-box integrations with Inventor, Revit, AutoCAD, SolidWorks, Creo, Word, Excel, PDF, and SQL Server. These applications typically need to fit into the enterprise infrastructure of the companies in order to be effective, and we've built these interfaces to make that easy. We also have a full API and can do customized interfaces when needed. Reusability is a really big thing. So prior systems have made this really hard. And what we found is that engineering is a collaborative process, that there's no one engineer that knows how to design these complex products. One guy knows how to do the materials, and another guy knows how to do the structure, another guy knows how to do the electronics, another guy knows how to do the aerodynamics, or whatever it happens to be. And if you can capture these rules into modular sets of rules and then mix and match them together, it's a very powerful way of accelerating the design and being able to leverage over and over again the investment in capturing those rules. In fact, we are in the process of opening up an app store, and we'll have third parties that are building these apps, including ourselves, but we have several third parties that have already built apps that will be going up on that app store, and you'll be able to, instead of having to create your own application, you can go buy and mix and match previously created applications. The authoring, as I mentioned, is fundamentally like a spreadsheet, but we have this editor that allows you to see the geometry, see the model, and the what we call the model tree, which is the hierarchy of parts and subparts. My library of building blocks down here, and my editor. And this is kind of like, down here is kind of like where it's like Excel, where I'm editing the expressions. Custom UI, being able to use the rules to drive and configure the user interface as much as the product. And this allows us to configure what the user's seeing and guide them to a valid solution. So it's a very important part, and especially the ability to do the interactivity. A lot of our customers embed these applications into their website. You can do it right through an iframe. You can set up a style sheet, make it look like your website. So that's that. And then if you want to see how it works, why don't you give me a minute and let me show you quickly how it works. Then we'll take a breath and you can ask you're welcome to ask questions now. I'm not trying to fill up your time here.
Yeah, no, that's fine. I'm wondering if you can hear me. Can you hear me?
Yes, I can. Okay,
good. My mic, it just says mute at the moment there, so I wasn't sure. Yeah, go ahead and show us a demonstration. I'll take out any superfluous conversation. It wouldn't be before I upload it to YouTube in the edit.
Sure. So what we're looking at is the place where you author the rules. So there's a lot going on here. You've got the hierarchy of assemblies and sub-assemblies. This house has roof group and frame gables, and it has walls and things like that. Over here we can see the geometry. We can change this to hidden line view or a wireframe view, etc. We've got control over that. We can change it to a perspective view or an orthographic view. As I mentioned, this is over here is kind of our library of building blocks that we build the design out of. And then if I click on one of these objects, actually I can click on one here, it'll take me to the tree over here. I'm going to actually click on this one. It puts that design into, whoops, let's see, mistyped, into our editor here. And these are kind of like the cells of a spreadsheet. So instead of being named C6 or something like that, it's named purlin spacing V, and it's associated with the frame gables. And if I look down here, this is like my expression in Excel. The purlin spacing is the pitch height divided by the number of purlins plus 1. So it's a simple expression about the relationship between the different properties of these parts. And this whole house design is made up of, hundreds of these simple expressions that set up the relationships. The expressions can be a conditional statement, they can be a mathematical statement, they can be an engineering calculation, they can be a reference to a data table, and so on. So that's the basics of how these models get built up. And then if I come up here, some of the properties at the root up here are, let's go here, are what we call parameters that drive the rest of the design. And so if this particular building length, if I change it from 350 to 400, for example, and hit apply, that change, just like changing the cell of a spreadsheet and it rippling through the spreadsheet, that change will ripple through the design and update our design. And, that's the basic interaction. We have some additional rules here for defining the user interface. We have more rules down here for defining how to make a drawing from this. I'm not going to go through all of that in detail right now, but if we want to look at the application that I've just created, I click on that run button and it shows my house in the user interface that I would share with others. This is the runtime version of this application. And so we're looking at, again, very high speed graphics. Again, no CAD system or anything. We're just running in the browser. We're looking at the user interface, and you'll notice that, so for example, the width is constrained between 125 and 400. If I put in like a negative number, it'll tell me I can't do that. But more importantly, that rule is driven by, or that constraint is driven by rules. And this is how we kind of use the rules to guide the user. So the width, the actual rule is that the width has to be less than the length. So if I change the length here, obviously it'll update my house, but it'll also update my user interface with different constraints based on those rules. This is a simple example, but the rules are used to drive how the user interacts with the model. And so I can make further changes here, like change the width to 400, change the pitch to 13, say. If I want to get this to fit in my screen a little better, if I want a hip roof instead of a gable roof, it can do that. And you notice that, it takes a couple seconds, but it's literally updating hundreds of parts and redoing the design just in a matter of seconds and providing with us a 3D graphical model to see. You notice I can change it to an L shape or a T shape. When I changed it to an L, it dynamically changed my user interface here to add some additional inputs. There are engineering rules built in here for sizing, so it's actually calculating the spacing and sizing of the roof members in order to handle the loads. If I want to, for example, add a door, so maybe I want a sliding glass door here, it'll add that in. And if I want to grab it and move it, it's using the rules to dynamically figure out where the best places are to put it, or where the valid places are to put it, I should say. And if I put it close, it'll snap into place to show me a preview. And if I let go, it'll re-engineer the design based on that new location. So it'll add some new studs here, remove some here, add a header, and so on, and re-engineer the design. All along while I'm doing this, it's creating a drawing, and I can switch to the drawing at any point in time. And it bill of materials, title block, four views. Automated drawings are notoriously hard to do and get right. So we use our kind of interactivity capability to allow the user to kind of move things around if they don't like where the drawing elements are. And then if we come back over here to our model, this demo doesn't show off all of our capabilities, but we can do materials, textures, shadows, render the solution so that it looks pretty nice. This is kind of a mediocre attempt at that here in this particular demo, but it gives you a flavor of that. And then we can generate documents from this. You probably noticed that it's been keeping track of the price. As every change I make, it adds or subtracts from the price appropriately. But if I want to create a proposal document, or a quote document, I click on that, and it pops up the Word document. Takes it a minute. And we have a customized Word document with pictures of our specific solution, with verbiage that's customized. The price is customized. The description is customized based on the choices that I made. We have a bill of material here. We can actually insert that drawing in here if we want. But we have a complete customized proposal document to show. And in addition, we can create a bill of materials. So in this case, it's an Excel document, and we can input from Excel, or we can output to Excel. We're able to understand or generate a complete output for things that can be stored in a spreadsheet. That's kind of the basics, and then I've got a bunch of other demos I could show you, but that kind of shows the basic functionality of the system. Maybe be good if you ask some questions at this point, and then maybe we can jump in and show you a few more things.
I've got quite a few questions actually. A lot of them were answered by within your presentation. So I'll wait for you to. I don't know if you have anything else to round off your presentation. We'll go back to it if my questions sort of require you to. But if you'd like to round off your presentation, I'll take it from there.
Why don't we use your questions to drive what else I show? So let's stop here and go ahead and ask some questions. And the one thing I haven't shown at this point is the actual integration to the CAD system. which I could show if you wanted me to, but I don't know if that's really of interest at this point. So
Actually, that is one of the questions I had. I was thinking, I mean, I don't know what order to ask the questions in, but I mean, I was thinking that this looks like a self-contained application within which there is a CAD element, if you like. I know it looks like the central element, the visual obviously is very impressive. But is that CAD part, the design part, something that's within the application, or is it an integration? Are you plugging into another CAD application to be able to use that sort of functionality?
So everything you saw was generated using our geometry, no CAD system. We have a library of elements, blocks and cones and cylinders and extrusions and just all kinds of shapes. We can do solid modeling operations and things like that right inside of K-Bridge. For many of our customers, the CAD is their central representation of the product. And so we're driving, we need to take their CAD models and put them into K-Bridge, and we need to drive their CAD models from K-Bridge. And so that's what I'm going to show you right here real quick. Now we're going to demonstrate how a knowledge bridge model can be transferred to a CAD system, in this case Inventor, although as we talked about before, we support multiple other CAD systems, but we'll show Inventor in this case, and we're going to work with a simple knowledge bridge model here just because it provides an easier way to explain how things are working. So we're actually going to start over on the Inventor side. Here in Inventor we have this simple block that's actually a factory file, and if we look at it we can see that it has three simple parameters: length, width, and height. And we also can see that there's a knowledge bridge add-in here. If we log into knowledge bridge, select our project, and adopt the part, I'm not going to do it now because I've already done it for this part, but if we adopt this part, it will create an equivalent knowledge bridge part with the same parameters, such that anytime we make an instance of that knowledge bridge part, it'll know that it needs to make a member file over here on Inventor, and it will parameterize it appropriately. We have a couple of different ways of getting the geometry matched up between knowledge bridge and the Inventor model. One is when we do adopt, we can also adopt the mesh, a STL representation of the Inventor part. That'll create a realistic looking part over on the knowledge bridge side, and for many parts that's appropriate, but if the part is flexible and can be parameterized, that process won't work. So what we do in that case is to create preview geometry inside of knowledge bridge that represents the geometry over here on Inventor, and oftentimes we'll make that a more simplified version than what's on Inventor. We just need to have it capable of showing us a visual of the product over on knowledge bridge. When we're actually going to manufacture the part, we're going to bring it over here to Inventor and flesh out the additional details. Once we've adopted that part, you can see over here we have the factory files for this simple example. There's an empty assembly file, and there's that block, and that's really all there is to it. And we can also see that at this point we've not generated any member files. We'll come back and check this later after we've run it and see how the knowledge bridge add-in has created those member files automatically for us. Now we're going to go back over to knowledge bridge, take a look at our table model here, we can see that as we walk down the model tree, if we look at the table itself, it has inherited from an inventor assembly document that allows us to, what it does is it says that anything from this point down below in the tree of the assembly that is an inventor part should be brought together into this new assembly as we're creating it over in Inventor. And if we look at, for example, one of the legs, we can see that it's an inventor part document, and that's where we create that one-to-one relationship with that block factory file, and it will know when it hits that it needs to make a block inside Inventor that's similar to the block over here on Knowledge Bridge. You'll also notice that we have some rules in our tree for creating the drawing inside of Inventor, and we also have some rules in here for creating the constraints that hold everything together, position the parts, orient the parts, and so on. And these rules are what will be driving the creation of our model over in Inventor. So now if we go back to Inventor and select the add-in, I'm going to actually log into Knowledge Bridge using the same credentials that I have over on the in the browser. I'm going to select the project that we were working on over there, that same table project. And once it's loaded, I can hit the update button here, and it's going to reach over into Knowledge Bridge and query that part. And as it does that, it's going to initiate this new assembly and build out a new generative assembly of this table inside of Inventor, and also, as you can see, build out the drawing. It's important to note that this assembly didn't exist before we just ran it. It's generatively creating the assembly that's needed for this particular table. So this is in contrast to a master model approach where you just are changing some parameters that are turning some things on and off within a master model. That approach is a very limiting approach for truly configured products and is difficult, if not impossible, to implement. This dynamic, generatively generated approach enables us to handle a much wider range of configurations and do it in a more efficient and lighter way. You also noticed, as I said, we have constraints in here, we have subassemblies, and so on that build out the model of our table. Over here you can see that our rules for the drawing have generated views, dimensions, notes, bill of material, title block. We actually have a detail view, a section view, and so on. We have, again, generatively created this drawing. This is not a drawing template that we just updated. It's a completely new drawing based on the rules that were indicated in the Knowledge Bridge model.
Well, I'm just going to ask whether the K-Bridge software and the things that you've done are all made from it's made from scratch, if the software is built from the ground up, or whether it's whether it uses maybe an open source kernel or whatever they call them as its foundation.
Well, we use a lot of different tools to build K-Bridge. So yeah, there are some open source components, but there's a lot of it that's developed by our own software development staff. Yeah, I didn't go through the history, but several of our key guys were part of the development of a thing called the ICAD system back in the 80s that was a kind of a pioneer in this industry. We developed a product that became part of the what was then Unigraphics is now, Siemens PLM NX product called Knowledge Fusion. We created the Inventor ETO product. So we've been through this a couple of times before. And when we created Knowledge Bridge, we wanted to, take advantage of everything we'd learned, but also take advantage of modern programming tools that enable us to do it faster and better and easier and more importantly on the cloud. And so, yeah, we use some tools, but it's mostly built from the ground up.
Yeah. That is very impressive. I mean, you mentioned other things as well. I mean, you do have a very solid background in this type of development, and it does show in the product itself. It's very, very impressive. I mean, in not too long ago, the idea of doing cloud-based 3D design was quite new and quite difficult. The average person wouldn't be able to access it or afford it. But it's becoming, I suppose, more accessible with applications like this. What kind of, I mean, I imagine that there's a lot of data processing involved, the cloud infrastructure that you have. I was curious about that. What kind of, I don't know, in terms of terabytes of, memory or data that's being processed. I mean, what tell us about the infrastructure that you have in the cloud that allows you and your customers to use Cambridge and the software in general?
Right. We have an architecture based on Azure, and it's running on Azure servers. It's doing calculations in the browser, so the actual geometry generated is being generated through the browser program basically, and the rules are being executed off of the servers. And so we have a pretty tight channel between the what the browser is doing and what's happening on the server in order to make that a really efficient process. And we have the Azure architecture to be able to scale it and have multiple servers and multiple users and support applications around the world. I've run this application running off the hotspot on my phone, sitting in a conference room in Tokyo, and it runs just fine. It's actually a highly efficient program the way it's been put together, and that's one of the keys. We in the past we had done this type of design automation for years, tied directly to the CAD system, and the problem is that CAD systems they're heavy, they're slow, they're not web enabled, and so it made it very difficult to do the kind of pre-sales configuration that you want to do on the web. And so, as I mentioned, when we started with Cambridge, that was a core, pillar that we wanted to build this on, is being able to do high-speed web-based configuration of engineered products. And so that's how we've approached it.
And for it being such an impressive product or software, I'm looking at the pricing. It seems, I don't know if I'm misreading it or misunderstanding it, but it seems very reasonable. Subscriptions start at $35 a month and go up to $150 a month. I would have thought it'd be several times your top package, really. For something like this. So yeah, it's quite reasonable. And given your customers as well, that would have been my other question. What type of customers and companies do you attract? It seems to me like there are construction companies. You did explain that they're mechanical machine builders, elevator systems and material handling and and so on. It seems like a very wide variety. I mean, can you give us an estimation of the size of the business, how many customers in total or turnover, anything that you can share, number of employees perhaps, anything that you can share that can allow us to gauge the size of company you are?
Yeah, so we're 40 people, and we're self-funded, and we have right now, I would say, about 30 Knowledge Bridge customers and adding new ones fast. You're right, the pricing is designed to be aggressive. We have, through the years, I've experienced various pricing strategies, but um, our strategy here is to make it easy, make it easy to get going, make it easy to, get an authoring seat, a couple of runtime seats, and try it out and learn and grow. And so our strategy with our customers is to, what I call plant seeds and then grow them. And we've had customers come back over and over and buy, a couple of seats to start with, and then buy, add 10 more seats, and then add 100 more seats. And, we have one customer that has 1,200 seats at this point. And, so the revenue, our target is to, have the maximize the revenue as the customer deploys and uses the application across their organization, not to try to get a whole bunch of money right up front. And honestly, that's been the strategy of prior systems in the past. And I think, one of the benefits of being on the web is it's mechanically easy for us to get people started, train them, and get them going. So why not make the pricing match that and have them be able to get started really easily?
Right. And the other thing I found impressive and wanted to ask about is I suppose you could call it the automation aspect of it. You were giving us a demonstration with the house where you could, with one click, have it make an L-shaped house from a rectangular house or building structure, and so on. It seemed you can change the type of roof it had, and so on. And although I've only used a very limited number of applications, 3D design applications, I don't remember them being as easy. I mean, I don't know how to use them as well, but that seems something quite new to me anyway. It seems quite new. I've heard of generative design. That probably doesn't qualify as generative design, but talk about a little bit, if you don't mind, about the automation aspect of it and I don't know if you have any generative design elements to it. Do you?
Yeah, well, I guess I would call it generative design. We are generating these designs entirely from rules. That house didn't exist until I put in the length, width, and height and told it what size and everything. And then it generates the model of that house, and then we can generate the design into the CAD system. So I definitely would call it generative design. The unique thing here, first of all, it's rules-based generative design, and in a lot of cases, generative design gets used for, kind of mathematical modeling of fancy layout of, spirals and things like that in architecture. But we're actually following engineering rules and relationships between parts, locations, orientations, configurations. We're following rules and generating a unique design based on their their specifications. And like I said, the unique thing here is not only can we generate it, but if you don't like where something is, you could grab it and move it, and that's really unique. No one else is, doing anything quite like that. So it enables us to do some applications where that interactivity together with the rules and configuration are what really make it unique. We call it visual configuration, or something like that.
When you designed it, what industry did you have in mind? That's my penultimate question. I suppose I don't know. Did you have construction in mind, or machine building in mind? What kind of customers did you expect it to appeal to first or most?
Well, this technology got built envisioned way back in the 80s. And the original vision was to capture engineering rules for collaborative engineering of complex products. What we realized is that while it's useful for that, when you capture a rule, the value of capturing that rule is multiplied if you're going to run that rule more and more times. And for products that are engineered to order, we're capturing a rule and running them over and over and over again, each time getting a different result based on the customer's different requirements. And so the value, the savings gets multiplied every time an order comes in, and you run the design again, you saved another 150 man hours, and then you run it again and you save another 150 man hours, and the value, becomes really, really high. And so we've tended to focus on industries where they're doing repetitive engineering tasks. And that is, the engineer to order business. And, we've listed several of them. It seems like a niche industry, but when you start listing them out, it includes, big companies like GE and Siemens and, companies like that make huge, big engineer to order type products, as well as, hundreds, if not thousands of mid-sized companies that, engineer and design transformers or heat exchangers or tanks or pumps or any of this type of equipment. And then you got into the whole building systems, custom windows and doors, HVAC systems, elevators and escalators, stairs, all sorts of things in buildings are engineered to order. So it's actually a pretty big market when you step back and look at it that way.
Right. And what are your, this is my final question, what are your future plans? How do you see things developing for you or progressing for you over the next few years?
Yeah, that's a great question. I think we're going to continue to push into more and more and more companies that do engineered to order products. I think the key element here, I mentioned way back at the start of the presentation, is capturing modular sets of rules and, for example, putting them on a store where you can share them with other people and mix and match them together. And I think if you're looking out way into the future, that it's that ability to share engineering knowledge in an active way, in a way that it actually applies the rules. It's not just a document with the rules written on pages of a book, but those rules actually do something. An ability to share those across engineering groups. I think ultimately that's going to be a pretty big deal. That's a kind of a game changer in the way that engineering gets done. It could be, and it's that's certainly the direction we're going to be pushing.
Okay. Well, Scott, thank you very much for your time and a great presentation and a very interesting interview. Thank you.
Okay, thank you.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.